Hi again. Today we'll be solving inequalities of rational expression. So the question is x plus 5 over x squared minus 9 is greater than or equal to 0. So the first thing I'm going to do, I'm going to draw a number line. So there we go. After that, what we need to find, we need to factor this. Factor the bottom. Difference of squares is greater. We're just going to say equals 0 for now. Now, your non-permissible values, non-permissible values, x equals plus or minus 3. So your non-permissible values is whatever makes the bottom 0. So 3 makes this bottom 0, and negative 3 also makes the bottom 0. So what you do, you go to that number line. There's 0 there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now you go and label your zeros or your non-permissible values. 1, 2, 3. So that is one of the non-permissible values, and then negative 3, negative 1, negative 2, and negative 3. So that's where negative 3 is. After that, I solve this for x. So what I'm going to do, I'm going to cross multiply all of the bottom here to get rid of the fractions to where 0 is, and therefore you end up with x plus 5 equals 0, because when you cross this, multiply this into the 0, it just becomes 0. 0 times anything is going to be 0. And therefore from here we get x is negative 5. And that is my x value there. And the x value is negative 5. So you go there, you make a circle and shade that circle. You shade it because there's an equal sign with the inequality sign right here. Now at this stage here, you want to find out where you're going to shade in this. Remember, your non-permissible values have to be put on your number line, because you got to test everywhere in between. Like you test in here, you test in here, and you test in there, and you test in there, because this x value and the non-permissible values that they divided this number line into 1, 2, 3, 4 regions. So this is region 1, if I may say, and then this is region 2 right here. There's region 3 right there, and then it's region 4 right there. So we got to test a number in each region. So in region 1, I'm going to test x equal negative 6. So just choose a number that's close to your 0 or your answer right there, so that it's when you plug it into here, you don't get big numbers. So now I'm going to test it into the inequality, and you have x plus 5. I'm going to write the bottom in factored form, x minus 3, x plus 3. I'm going to sub in the negative 6. So I got negative 6 plus 5 over negative 6 minus 3, and negative 6 plus 3. After this, just figure out the top is going to be negative. This is going to be negative 9. So negative, and this also negative 6 plus 3. You're going to get negative there. So negative times negative on the bottom is positive. Negative divided by positive, you get negative. When you get a negative number, is that greater than or equal to 0? No. So you don't shade in region 1. Okay. Now in region 2, I'm going to test a number in between here and here. So I'm going to test x equals negative 4. And if we put negative 4 into the x there, negative 4 plus 5 all over negative 4 minus 3, negative 4 plus 3. Now on top, I'm going to get positive. Negative 4 plus 5 is positive. And negative 4 minus 3 is negative 7, so negative. And negative 4 plus 3 also gives me negative. That's going to be positive over positive, which gives me positive. Is that greater than or equal to 0? Yes, it is. So here is true that negative 4 will give me a true statement here. I'll get a positive number. Any positive number is definitely greater than or equal to 0. So I'm going to shade in here. Now let's test in this region. That region, instead of testing a number that's close to the non-permissible values, 2 or -2, when you could test 0, always test 0 because it's a lot faster to work with 0. So in region 3, I'm going to test x equals 0. And when you're testing x equals 0, you just get rid of the x's, okay? Like you don't even have to go there. Like if you make this 0 and the 0, this is gone. So you end up with 5 over -9, which is negative answer. And negative answer, is it greater than or equal to 0? No, that's false. So you don't shade where 0 is. And if you test any of these numbers, it will give you the same thing. It will give you a false statement in this region right here. Now let's test something in here. So the next to 3, I'm going to test 4. So in region 4, I'm going to test 4. Okay, region 4, I'm going to test 4. And if I sub in 4 there, I'm going to sub it into this equation right here. So 4 plus 5 all over 4 minus 3 and 4 plus 3, which gives me positive on top. 4 minus 3 is positive and 4 plus 3 is positive. So positive over times positive is positive, positive by positive is positive. So overall it's going to be positive is positive greater than or equal to 0, because that satisfy that statement. Yes, true. Any positive number is greater than or equal to 0, so it's true, and therefore you shade since it's true. So you shade in this region right here, okay? And therefore my solution, I'm just gonna write that right here. My solution is x is between -5 and -3, or x is greater than 3. And you notice that I have an equal sign here because of the -5 that we found here. It's included since the inequality sign has an equal with it, right there, greater than or equal. But the non-permissible values always have an open circle, and that's why we didn't include an equal sign there. And that's the answer for that one. And that's it. So go ahead and hit that like button, subscribe, share with others so they could benefit. Your support to this channel is important. Thanks for watching. Till next time, bye-bye.